Hello, good day viewers. Welcome back once again. Today we have a very interesting hexic equation. We have x to the power of 6 minus x cubed. This is equal to 2. Here we'll be solving for all 6 solutions. Amazing, right? Now let's get into this video. From this term right over here, x to the power of 6, we can write it as x cubed, then raised to the power of 2. Because 3 times 2 here will give us this 6. And here we have minus x to the power of 3. Then this is equal to 2. At this point, the best decision to make here is to let x cubed equals another variable. Let's say m. So x to the power of 3 squared will become m squared. Minus x to the power of 3 will become m. Remember, we're subtracting that 2 and the whole of this equals 0. Okay, now from here, make use of the general quadratic formula, or even this can be factorized. I think so. Now, m squared times negative 2m. Oh, is that negative 2m? No, negative 2, right? M squared times negative 2 will give us negative 2m squared. So we're going to look for two terms that their product will give us this, and their sum will give us negative m. So these two terms, if I'm not mistaken, should be negative 2m and positive m. Because negative 2m times m will give us negative 2m squared, and negative 2m plus m will give us negative m. So we're going to write negative m using the sum of these two terms. So that will become m squared, so minus 2m plus m. So we can see then minus 2 here, this is equal to 0. So here m is common, so we factor it out. So we have m minus 2 here, and here we just have 1, right? Then m minus 2, this will be equal to 0. From here, this is factorized as m plus 1 multiplied by m minus 2, which is equal to 0. Okay, so from here, this implies that either m plus 1 is equal to 0 or m minus 2 is equal to 0. And from here, m is negative 1, and from here m is equal to 2. Good. Now let's just recall back that x cubed is equal to m. So we're going to have two cases here. So we have case 1. In our case 1, when m is equal to negative 1, then x cubed will be equal to negative 1. Now adding 1 to both sides, we get x cubed plus 1 will be equal to 0. So from here, this is same as s cubed plus 1 cubed is equal to 0. Now let us recall the sum of two cubes formula. A cubed plus b cubed, this is equal to a plus b multiplied by a squared minus ab plus b squared, right? So using this property here, this will become x plus 1 multiplied by x squared minus 1 times x, which is x plus 1 squared 1. This is equal to 0. Okay, so at this point here, we have either x plus 1 is equal to 0, of which we have x to be equal to negative 1, and this is a solution. Or we have here, this equals 0, which is x squared minus x plus 1 equals 0. And when we use the general quadratic formula, we get x is equal to negative b will be 1 plus or minus square root of b squared minus 4 ac will be square root of negative 3, which is iota root of 3, then divided by 2. We're very familiar with this, how to make use of the general quadratic formula, right? Okay, so we're done with our case 1. Let's go to case 2. Our case 2 is awesome because it will involve a lot of manipulations. So we have this case when m is equal to 2, right? So this will imply that x cubed is equal to 2. Now we have x cubed minus 2 is equal to 0. Now this 2 here, we can write it as the cube root of 2, then cubed, which is equal to 0. Okay, we all know that the cube and the cube root can cancel. So we have just 2. Now here, let us record the difference of two cubes formula. A cubed minus b cubed is equal to a minus b multiplied by a squared plus ab plus b squared. So from here, this will become x minus cube root of 2 multiplied by x squared, then plus cube root of 2 times x will give us cube root of 2x, then plus cube root of 2 squared. Let us take note of this. When we have the mth root of a and we're raising this to the power of n, this will be same as putting this n as the power of a under this root sign. So that will become the mth root of a to the power of that n. Amazing, right? So this is telling us that the cube root of 2 squared will be same as the cube root of 2 squared, which is 4. And this is equal to 0. So from here, when this is equal to 0, we get x is equal to the cube root of 2. So we have a solution. When this right over here is equal to 0, we get x squared plus the cube root of 2 times x plus the cube root of 4. This is equal to 0. Using the general quadratic formula, we get x is equal to negative b with negative cube root of 2 plus or minus square root of, now b squared will be cube root of 2 squared, which we know earlier that is cube root of 4, then minus 4 times a times c, which is 4 times this cube root of 4, and we are divided by 2 times a, which is 2 times 1. So from here we get x is equal to negative cube root of 2 plus or minus square root of, this minus this will be negative 3 times that cube root of 4, right? So negative 3 times the cube root of 4, then divided by 2, and which we can simplify as negative cube root of 2 plus or minus square root of negative 1 is iota, right? Then times the square root of 3 times the cube root of 4, then divided by 2. So here we have all 6 solutions. So for real solutions, so we have x is equal to negative 1 and cube root of 2. And for complex solutions, so we have x is equal to 1 plus or minus iota root of 3 divided by 2. And we have this right over here, that x is equal to negative cube root of 2 plus or minus iota square root of 3 multiplied by the cube root of 4 divided by 2. Wow, I love mathematics so much. If you love mathematics, please give me a like, comment, and share. Please don't forget to subscribe and turn on the notification button so that you'll be notified anytime I upload my exciting videos. Thank you and bye-bye.